Alright, so hey 8th graders, Juri and Isaac, this is for you. So we've got lesson 10-2 to do today. We're solving equations still, but it's going to be when we're solving equations with variables on both sides. So for example, you got this one, 12x plus 5 equals 6x plus 17. So they give you that example, they go through step by step what you guys do. So the first thing is you want to combine like variables. So we can't solve this if there is variables on both sides. So either the 12x has to move over to this side with the 6x, or the 6x has to move to this side with the 12x. Okay, so it doesn't matter which one you move, but one of those variables has to come to the other side before you can solve. Okay, so that's always your first step when you see that. The second step, it says use inverse operations, subtract 5 from both sides. So once you combine your x's together, so for example 12x minus 6x, you just subtract that like normal. That just gives you 6x plus 5. This canceled out, so they didn't write that anymore. Then they put the 17. From there, that's just a two-step equation. So you're just going to get x, or isolate x, by using inverse operations, doing the adding subtracting number first, which would be the 5. The inverse of adding 5 is to subtract 5. You do that step, you rewrite it. This is 0, this becomes 12. You bring everything down. You use inverse operations one more time to get rid of that 6. The opposite of multiplying 6 and x is to divide by 6. So you divide both sides by 6. That gives you 1x equal to 2. I personally don't write this as 1x. I just cancel out the x's and write x equals 2. But they're being very precise and they're putting it as 1 because 6 over 6 is not 0, it's 1. But 1x is just x. So in essence, it does kind of just cancel out. So you get x equals 2. They call that the multiplicative identity property, that 1x is equal to x. Okay? Because you would just divide by 1, and anything divided by 1 is itself. So that's what they're saying there. Okay, so in the equation, okay, so then they just, so this is just checking, right? So you got x equals 2, so you just plug the 2 back in where the x's are, and then you evaluate both sides, and if you get both of them equal to the same value, then you know that you did it right. Okay, so there's always a way to check it. So when kids tell me, is this right, I tell them, well, you know how to check it. You can do that yourself. And it's really empowering to be able to do that yourself. So, if you're on a test, that's something that you really should do. Okay, so on this bottom part, they want us to take all these and solve them and provide an explanation for each step. I'm not going to do all of it. I'm just going to do A and B, and then I'm going to let you guys, well, let's see, I'll do one with fraction. No, that's fraction. I'll do A and E, and then I'll let you guys do B, C, and D. Okay? So just know you still have to do it, but I'm just going to give you an example and you can do the other two for time's sake. So I'm going to go over here, I'm going to put A. So for A, we've got 2 minus 3 halves, and that's x plus 1 here, and then equal to 6x minus 9. Okay, so let's see, hopefully it focuses. It's not focusing, let's see. Okay, so we got this. We need to simplify both sides before we can do anything though, so let's go ahead and do that. So this side is completely simplified, but this other side with the parentheses and the number on the outside is not. So let's go ahead and distribute into the parentheses so we can simplify that. So this is just going to be negative 3 halves times x, negative 3 halves times 1, positive 1. So I'm going to rewrite the 2, Negative 3 halves times x is just going to be negative 3 halves x. And negative 3 halves times positive 1 is just going to be negative 3 halves. And I'm going to rewrite this other stuff on the other side. And so we've got it almost simplified, but this is a number and this is a number that we can combine. So these are like terms on this side, so we need to do that first. So 2 minus 3 halves, well, let's think about this. So if you want to add or subtract fractions, you're going to have the same denominator. So let's rewrite the 2 as, let's rewrite the 2 with a denominator of 2. So if I have a denominator of 2, right, let's think 2 over 1, right? If I change the denominator to 2, that means I multiplied times 2 to get the denominator of 2. So 2 times 2 up here would be 4. So I'm going to take out the 2, and I'm going to write it as 4 over 2. So 4 over 2 minus 3 halves, that's just going to be 1 half. So I'm going to put negative 3 halves x plus 1 half, because 4 halves minus 3 halves is 1 half. I'm going to rewrite this. You also could have put that in the calculator, 2 minus parentheses 3 halves, if you want to do that. Okay, so from here, this is completely simplified, this is completely simplified. So now I can use inverse operations to solve. Oh, I forgot, I need to put the steps. So here, we were simplifying both sides. And then here, we're going to solve. Or no, sorry, we're going to combine like variables across the equal sign. Okay, so let's do that. I am going to choose to move this to this side. So I'm going to add 3 halves x to both sides. So that'll cancel out here. I'll rewrite this as 1 half equals, if I were to rewrite this with a denominator of 2, that would end up being 12 over 2. 12 over 2 plus 3 over 2 would give me that would give me 15 over 2. X 12 over 2, yep, and minus 9. And then from here I can use inverse operations again to, well, I'm going to use it, I guess, for the first time to solve. Well, I didn't, I guess. You still use inverse operations here to combine the x across the equal sign, but you're going to continue to solve. So here I'm going to put here, use inverse operations to solve. Okay, so I'm going to first add 9 to both sides, because that's the adding subtracting number. Remember, our goal is to get x by itself, so both of these numbers got to go. This will be the first one. 1 half plus 9 is just going to be 9 and 1 half, or we can write it as an improper fraction, which would make that 18 over 2 plus 1 would be 19 over 2. So 19 over 2 equals 15 over 2. And at that point, I can divide both sides by 15 over 2. So remember, if you are dividing by, oh sorry, it's kind of blurry. So So remember, if you're dividing by a fraction, you're just going to multiply by its reciprocal. So keep change, flip, right? So this will be 19 over 2 times 2 over 15, which is just going to be 19 over 15. And you can put that in and check, but I don't have very much space here, so I'm not going to do that. So that was A. So we need to do E. So let's go ahead and do E. I'm going to do E up here. Hopefully you're doing this like maybe on a piece of paper, because you do need a lot of space for this. So on E, we got 1/2 18x minus 8. Equals 6x minus 7/2. Oh, I don't need a parentheses there. I don't know why I did that. Okay. So that's correct. Yes. Okay. So first off, I need to completely simplify both sides. So I'm going to put here simplify, which would mean to distribute and combine like terms. Okay, so first I'm going to distribute, because I have a parentheses with a number on the outside. So to simplify, I got to multiply that times each term in here. 1/2 times 18x, that's going to be 9x. 1/2 times negative 8, that's going to be negative 4. Equals 6x minus 7/2. This is completely simplified, this is completely simplified. I wrote down combine like terms, but it looks like we don't actually have to do that, so I guess you don't even have to write that. So from here we need to combine our x's across the equal sign. Combine x terms across equal sign. So I'm going to go ahead and move the 6. So there's a positive 6, the opposite is to subtract 6. That'll cancel. I'll get 3x minus 4 equals negative 7/2. From there I want to get x by itself. So I'm going to start with the adding subtracting numbers. So this will be plus 4. This becomes 3x equals, and if I want to do any adding or subtracting here, I'm doing it without a calculator, but you guys do have a calculator, so you could just put this in the calculator. But if I were to convert this with a denominator of 2, that would make 8 over 2. So 8 over 2 minus 7 over 2 would just be positive 1 over 2, 1/2. So 3x equals 1/2, divide by 3 on both sides. X is going to equal, let's multiply this by the reciprocal, so it's going to be 1/2 times 1/3. So that's going to give us 1/5. Sorry, not 1/5, 1/6. Sorry. I was adding instead of multiplying. Okay, so that would be your answer there. And we forgot to put here that we started solving using inverse operations. Okay. So you got A and E, so you should be able to do these other ones. If you want to go back in the video and kind of review what we did, you can do that. I'm going to go to the next page. So from here we got some word problems. And they give you an example here. Example B says Kurt is surveying a triangular plot of land. He was told that the longest side of the region is 30 feet longer than 1/3 the perimeter. So you could write that out as longest side equals, well, I guess they can, yeah. The longest side was 30 feet more than 1/3 the perimeter, right? So that's what they said. So they just transcribed that in algebraically from words to algebra. And the shortest side is 1/4 the perimeter. He also knows, wait, okay, so he also knows that the longest side is 60 feet longer than the shortest region than the shortest side of the region. So the shortest side was 1/4 the perimeter, and the longest side is 60 more than the shortest side. So combine all that together, you get this equation. You solve it just like we did before. Okay, and they gave you another example here. Same thing. You have a number such that 1/2 the number is decreased by 2, so this would be 1/2 x minus 2. When they say a number, that means x. So 1/2 a number decreased by 2. And then that's equal to 1/3 the number increased by 1. So they just took the words, transcribed them algebraically, made an equation, then solved it. Then they checked. Okay, so on this one, it says create a model and solve. So we're going to do that real quick. And feel free to pause the video and try to figure it out on your own and then see if you get it right. So that would actually be the most beneficial for you to learn this. Okay, so 2/5 a number, that's going to be 2/5 x increased by 6, so plus 6, is equal to 3/4 the number, so 3/4 x decreased by 8 minus 8. Okay, so we made our model, now we just need to solve it. Wait, create a model, yeah, and we have to solve, okay. So we got to combine our x's first, right? So we didn't have to simplify. This is completely simplified. I can't combine an x term with a number term. Same thing here. I can't combine an x term with a number term. There's no other numbers. There's no other x terms on this side to simplify with. So they are both completely simplified, so we can go ahead and start solving. So I'm going to bring the 3/4 x over here. So at this point, this is where the calculator would come in really handy. You could put this in parentheses in the calculator and subtract it, and it'll give you your fraction. You'd have to go to math fraction to get a fraction. I don't have that luxury, so I'm going to have to find a common denominator. So this is going to be 20 over 8 and 15 over 3, subtract that, that's going to be, no, that's going to be 7. So this is going to be -7/20 x plus 6 equal to -8. Okay, so let me just check that. 5 times 4 is 20, 2 times 4 is 8, 4 times 5 is 20, 3 times 5 is 15. Yeah. Subtract that. Yes. Okay, well that's good. So now we need to go ahead and solve for x. So x needs to be by itself. That means that this number 6 and this fraction, -7/20, have to go on this side. This is my adding subtracting number. This is my multiplying dividing number. This always goes first. So the opposite of adding is to subtract. I'm subtracting 6 from both sides. That's going to give me -7/20 x equal to -14. From here I'm going to divide by -7/20. Again, you can put this in your calculator if you put this in parentheses. But also know that you can multiply by the reciprocal, which would be 20 over -7. 14 divided by -7, that would give me 2. 2 times 20 is 40. So x is 40. Okay, so let's see those things. Okay, I'm going to go ahead and do some of these as well. So on B, it says Marcus has created a budget for his upcoming trip to the theme park. Admission is 40% of the budget. So 40% would be 0.4. And we don't know what the budget is, so we're just going to say that's B. So that's going to be our variable. He plans to spend, okay, so admission is, I'm going to put here admission equals 0.4b. He plans to spend 32% of his money on food. Okay, so 32% of his money. Okay, so food is going to be 0.32% of his budget, and souvenirs will be 0.23% of his budget, and 0.5 is going to be emergency. Sorry, 0.05 would be for emergencies. He knows the admission will be $6 more than he will spend on food, souvenirs, and emergencies. Okay, so this is where it gets a little bit tricky. So it says he knows the admission. So admission is 0.4b. So his admission is going to be $6 more than he will spend on food, so spends 0.32 on food, 0.32b on food, plus 0.23b on souvenirs, and plus 0.05b on emergencies, and then they said that 6 more than that, so plus 6. How much money will Marcus need to take to the park? Okay, so I'm going to go ahead and take this and I'm going to solve it. I'm going to do that over here on this side. So 0.4b, sorry, let me see if I can fix that. There we go. 0.4b is equal to 0.32b plus 0.23b plus 0.05b plus 6. So when you combine our like terms, this is a b term, this is a b term, this is a b term, because that's part of simplifying, right? So you got to add those together. You can do that in your calculator quickly. I won't be as quick. That's going to be 10. It's going to be 6. Okay, so 0.6. So 0.6b plus 6. And I got to combine the b's across the equal sign, right? Because I can't solve if they're both on either side. So I got to either move the 0.6b over here or move the 0.4b over here. If I move the 0.4b over here, that's kind of weird because that leaves that as 0. So I'm going to go ahead and move the 0.6b. So I'm going to subtract 0.6b from both sides. Because remember, we have to use inverse operations if we're going across the equal sign. So that cancels. I get 6 here. This would end up being negative 0.2b. And then I'm going to divide by negative 0.2. And your b is going to be, well, let me rewrite this. So you can put this in your calculator. I'm going to do something else because I'm doing this in my head. Well, not in my head, but by hand. So 0.2 is actually 1/5. So this is really 6 divided by 1/5, negative 1/5, which equals 6 times negative 5 over 1, which is going to equal negative 30. So B equals negative 30. Wait, how does that make sense? Wait a second. Okay, so we subtracted 0.6. That gave us 0.2. And we divided by negative 0.2. The budget is negative 30. How much money will Marcus need to take to the park? Why did that not work out? Did I do this right? 5, 3, 2, 10, that's 6. We got 0.4. It's interesting. Okay, sorry, so I paused the video just for a second because I was trying to figure out why I came out with a negative 30. I went through it again, I checked my answer here, and I got negative 12 equals negative 12, which means it is the correct answer. I went over how I set it up. It has to be the way I set it up. So what I would put on this question for B is when it says how much money will Marcus need to take to the park, I would say these restrictions on his budget do not work. So you can't take negative $30 to the park with you. That can't be your budget. So if that's the only number that works, then that means that there's not a real solution for this with the constraint that they gave us. I would maybe put for real world application. Okay, so I would put that for that question. And I'm already at like 30 minutes or so, so I'm going to go ahead and jump down to maybe like, well, I'm going to try to do this page at least. Okay, so on number 1, here it says, John and Danelle know that regular exercise strengthens your heart. They know that a person's heart rate should not exceed a certain limit during exercise. The maximum rate R is represented by the equation R equals 0.8 times 220 minus Y, where Y is the person's age in years. Determine the age of a person whose maximum heart rate during exercise is 164. Okay, so they give us the equation. Y is the person's age. Determine the age of a person whose maximum heart rate during exercise is 164. Okay, so this is pretty simple. So all we need to do here is they want us to figure out the age, that's Y, so they want us to solve for Y, and they gave us the maximum heart rate of that person, which was 164. So we're going to substitute 164 for R, so we're going to put 164 equals 0.8 times 220 minus Y. We're just going to solve for Y here. I guess this is just a practice of linear equation because this doesn't have variables on both sides. You're just going to solve this like you normally would. So I would distribute and simplify. So I have to figure out what 0.8 times 220 is. So if you put that in your calculator, 0.8 times 220, that would give me 176. This would be 0.8y, negative 0.8y equal to 164. I'm going to rewrite that here. If you want to isolate the y, you're going to get rid of the adding subtracting term first. This is positive, so you would subtract 176 from both sides. When you do that, you're going to rewrite that 164 minus 176. That would equal negative 12. So you have negative 12 equal to negative 0.8y divided by 0.8. Negative 12 divided by 0.8 equals negative 15. So negative 15 equals y. Okay, sorry guys, so I thought that I had gotten another negative number, so it messed me up. So this is actually divided by negative 0.8. I guess I'm just going too fast. So this one would be positive 15 because we got negative 12 divided by negative 0.8, so this would be a positive 15. So the person would have to be 15 years old. On that one. Okay, so then on number 2, the formula A equals P plus PRT gives the amount of money A in an account where the initial deposit is P and the money grows at a simple annual interest rate of R for T years. Assume no other deposits or withdrawals are made. How much money is in the account after 5 years? So our years was T, and $20 deposited, annual interest rate is 4%, so R equals 0.04, and our equation is A is the account where the initial deposit is P, initial deposit is P, so it's going to be P equals 20, so the amount is going to be 20 plus 20, that's where the P is, right? I got 2 P's. And then, let me focus this. And then you got your rate, which is 0.04, times your years, which is 5 for this one. And then you can just put that in your calculator. So let's see here, I got a calculator. So that would be 20 times 0.04 times 5, and that's going to be 4, and then 20 plus 4 is 24. So this would be, so your amount that you would gain would be, well, the total amount that you would have in your account after 5 years would be $24 if you just left it there. Okay, and then it says how much was deposited in the account if the amount in the account after 6 years is 1770. So the amount in the account after a certain amount of years is 1770. That would be A. The years T is 6. The interest rate is 0.03. So this is going to be a little bit different. This one is going to be, instead of A equals all these numbers, we have a number for A. That's going to be 1770. And then our P is what we don't know, so it's going to be P plus P times 0.03 times 6. Okay, so we've got that written down. So this is going to be 0.03 times 6. Let's put that in our calculator. So it's 0.03 times 6. That's going to give me 0.18. Well, I should have known that. So that's 0.18 P plus P equals 1770. These are like terms, so I can combine those. So this would just be 1.18 P equals 1770. Because this was a 1, right? If it's just a P, it's a 1P. So 1 plus 0.18 is 1.18. And then finally, to get P by itself, I'm going to divide by 1.18 on both sides. And that should give me P equal to, so let's see, 1770 divided by 1.8. Put that in my calculator. So that's going to be 15. So P is $15. So that person started out with $15 in their account. I'm going to let you do C on your own. I'm going to move on. The set of numbers 1/2, 3, 6, 0.17, 0, 11 contains possible solutions to the following equations. Determine which of these numbers is a solution to each of the following equations. Show all work to justify your conclusions. Okay, so if we want to prove that these are solutions, determine which of these numbers is a solution to each of the following equations. Show all work to justify your conclusions. So we could start just plugging numbers in and simplifying and seeing if they equal each other. Right, both sides, but that would be really long and tedious. It would be better just to solve for x and see which one they would be. So I'm just going to do A because you should know how to do this by now. I'm just going to distribute to simplify this side. This will be 4x plus 8 equals 5x. I'm going to rewrite this side. Combine your like terms. The 4 and the 5 are like terms. That gives you 9x plus 8. From here, we're going to combine the x's. So I'm going to subtract 9x from both sides. This is actually going to be a very special case because if you notice 9x cancels here, it also cancels here because this is 0, this is also 0. So you get 5 equals 8. And you might have a case where that happens. When that happens, this is a no solution. That is a no solution because it doesn't make a true statement. And they even wrote that in down here. No solution is when if there is no value for the variable that will create a true mathematical statement. This is not a true mathematical statement. Okay, so I want you guys to do these other, well, actually, you know what, I'm going to just go ahead and do this because they might have one where this is many solutions. So I'm going to go ahead and do the rest of these. So this is already simplified on both sides. So I just need to combine my variables across the equal sign. This will become 4x minus 10 equals 14. I want to get x by itself, so I'm going to add 10 to both sides first. Rewrite that, that's going to be 4x equals 24. Divide by 4 on both sides. It's going to give you x equals 6. So that would be 6. Next one, I have to simplify this, so this is going to be distributed first. So this will be 3x plus 3 minus 15. Rewrite this over here. Combine my like terms, that's going to be 3x. 3 minus 15 is going to be negative 12. Okay, and I'm going to combine my x's, right? So I'm going to subtract 3x from both sides. Again, you got this same thing where this cancels and then this also cancels. And then that gives me negative 12 equals negative 12. Notice how this is a true statement. Negative 12 does equal negative 12. So this is going to be a case of infinitely many solutions. So these are special cases. Okay, so let's turn this page over. This is the, well, not this page. So go to the next page, and this is the last one. I know this has been super long. So all they want us to do is identify which one is a no solution, one solution, or infinitely many, and why are they correct. So the equation each student has reason their equation as having no solution, one solution, infinitely many. Okay, so this one would be a no solution, right? Because it's not a true statement. Not a true mathematical statement. This one is one solution. The variable equals a number. The variable can be isolated. This is infinitely many. Solutions. It is a true mathematical statement. Write a real world problem for the equation 7x minus 10 equals 3x plus 14. Let's see. We could say something like I don't know. Hold on, I have to think about this. I'm just going to write it as, it has to be a real world problem, so. The admission to a park is 7 times the amount in Jake's pocket. Decreased by 10. And the amount of admission is equal to 3 times, so the amount of admission is, we're going to put also equal to 3 times the amount in his pocket increased by 14. Maybe you guys can come up with something better, but that's the best I can do right now. I can't think of a good real world problem for that, but you can come up with one maybe better. But just work on your practice problems. Maybe Isaac and Jaree can work together and just try to get all of your practice problems done for 9-1, 9-2, and 10-1 and 10-2. All right, thanks. Bye.